Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, we'll be talking with Professor Mo Ehsani, Ph.D., PE, structural engineer, president and CEO at QuakeWrap Incorporated, about how the field of structural engineering has evolved with the introduction of composite materials like FRP or fiber reinforced polymer, the advantages that FRP technology has over traditional concrete and steel repair solutions, and the differences between infrastructure repair projects in the water and on land. Professor Ehsani will also share some examples of successful infrastructure repair projects that have utilized FRP technology and will provide insights into how this technology can benefit structural engineers. I'm your co-host, Matt Picardal. Now let's jump into our conversation of the week with Mo. Mo, welcome to the show. Can you tell us about your background and what you do on a daily basis at QuakeWrap?
Thank you. I'm glad to be with you today. Basically, my background, I'm originally from Iran. I came to US after high school back in 1972 and went to University of Michigan, where I received my bachelor's, master's, Ph.D. all at Michigan. I always said the other schools were wise enough not to admit me, so Michigan stuck with me. And then I came to Tucson in 1982 to start as a professor of structural engineering at University of Arizona. And then it was, earlier kind of in my career, as you know, a lot of professors were supposed to have a funded research program. So I was looking at new ways of new areas to get into research funding, and came across this use of carbon composite materials for which at the time they were being primarily used in the defense industry, and the cost was really high. But luckily, about the same time as we were getting towards the end of the decades of the 80s, there was a collapse of the Berlin Wall and the end of the Cold War. So the military's interest in these materials dropped and their cost went down quite a bit. So they became feasible for construction. And that's then really the rest of my career, the last 35 years. It's been working and developing new products. I have about 20 patents now on these things. And finally, about 12 years ago, in 2010, I bit the bullet and left the academic life, and that 10-year full professor, 10-year lifetime guarantee of a paycheck. And I said, no, I want to be an entrepreneur and give it a try.
Yeah, that's really interesting. I want to ask you about the career path later on. I know you got a really interesting career path, but for the field of structural engineering, with the introduction of composite materials like FRP, how has that affected the way we approach infrastructure repair projects?
Yeah, well, let me actually tell you that when we started looking at these, our initial interest was for repairing. Some of your audience may remember that in the 1989 Loma Prieta earthquake, where some of the bridges in San Francisco and Oakland, they collapsed. And the major problem with these bridges was that they had enough reinforcing steel in the longitudinal direction in the columns, but not enough ties or hoops around them. So we came with this idea that you could actually take a carbon fabric, which is very strong in tension, and if you wrapped it around the column of a bridge, you could make it earthquake proof. Thus, the name QuakeWrap was really for just that one application of wrapping these fabrics around the columns of bridges. But then over the years, we have realized that these materials really open up a lot of doors for all kinds of structural engineering applications. And in fact, today, if we look at the business that we do in QuakeWrap, probably less than 10%, 5 to 10% maybe seismic upgrade activities, but the rest of it is all about corrosion repair, strengthening, and these materials, I think they are some of their main key advantages is that they're very lightweight. They can be applied quite easily and quickly, and have an excellent, tensile strength, and they're durable. So they, they, unlike steel that is that corrodes, these materials, they last virtually forever. So it's really a unique type of product to be used in a lot of these engineering applications.
Yeah, that's really interesting. So to me, it kind of seems like you kind of get rid of some of the cons of steel tensile reinforcing with the corrosion. And could you explain some of the advantages of the FRP technology over the traditional concrete and steel repair solutions?
Yeah, so for example, first of all, anytime that you want to retrofit a building, in fact, this would be interesting. The way we started, our first job with this company was a job that we did in Southern California in Glendale. And in fact, that really kind of goes back to tell you that why the traditional method wouldn't work. This was a masonry wall that was, this was now a few years later, it was damaged in the Northridge earthquake. So this was about 1994. So the wall was damaged, and the traditional repair would have been to dowel some rebar into this wall and put a new mesh of reinforcing steel and then gunite on it. Well, this, which is the conventional repair even today we use on a lot of projects. Well, they add about 6 to 8 inches of thickness to the wall. And that building happened to be sitting right on the property line. So they didn't have 6 or 8 inches of space to thicken the wall. And that's how we got our very first job at the beginning of the company, was with that job. In fact, if any of your listeners are in Southern California, I never forget the address. It is 222 North Verdugo and in Glendale. And every time I go to Southern California, if I drive by that, it's a dry cleaning store, and you can drive right next to the wall because it's in the parking lot, so it's open to the public. But that's so that's really one of the advantages, is that if you use traditional reinforcement like using steel rebar, then you have to chip away the concrete and once you put the rebar, you have to protect it with an additional layer of concrete. It adds a lot of weight to the building. Also, imagine if you have to do these, on upper floors of a building. Let's say, you want to strengthen a beam on the 5th floor of a building. Well, if you have to take a steel beam to take under there to support it, for example, or take a lot of concrete, that just, adds so much time and cost to the construction. With these materials, virtually like a roll of carbon fabric and a couple of buckets of epoxy, you could put those under your arm and go up the passenger elevator to that floor and strengthen these. And, usually when you apply these, the materials cure in a day or so. And the next day, you have a material that is 2 to 3 times stronger than steel. And from, if you look at it from an engineering point of view, for example, when we are retrofitting or strengthening a slab or beam, we put these materials directly on the tension face of the element. So you have the maximum depth for your moment arm. It gives you a pretty good moment capacity because of the having that high moment arm also.
And yeah, it seems like, like you were saying, in terms of the ease and constructability of it, you just need a bucket of epoxy and pretty much a roll of carbon fiber wrap, and you're pretty much gluing on tension or tension seal or a tension element, and that's all the repair is. It's and you get the tension using the properties of concrete. So
and exactly, as you got it right, but also think about it that, because these are kind of made, I always simplify this to say it's almost like putting a wallpaper on your structure. But you take, a roll of this fabric with you. So even if you have a 30-foot long span that you're trying to repair, you don't need to take a 30-foot long element with you, which would be really challenging in an occupied building. Here it's a roll of fabric, and you just open the roll and you cut the length that you need, 30, 40, 50 feet, whatever, and apply it. And that's really just like, these kind of things, they add so much to it, because we have, I also own a construction company. and we install all of these. And so I really appreciate the fact that how easy, the ease of construction is something that, for some of us structural engineers, maybe we don't worry about that too much, but I have to deal with that aspect of the job too. And the fact that these can
Yeah.
go on easily, it really matters a lot.
Are there any limitations to FRP technology? And if so, how do you overcome them?
Yeah, so one of the main differences between FRP and a lot of other products, engineering products, is that composite materials, because remember, they're made out of very individual fibers that are made into a bundle of fibers that they call a tow, and then those tows are taken to weave a fabric out of it. So the strength of these materials comes from the orientation of the fiber. So you could, for example, have what we call a unidirectional fabric where all of the fibers are aligned in one direction. And if you're strengthening a beam, for example, you would put those fabric, you would run it along the length of the span on, let's say, on the bottom of your beam. And so it's really effective this way. But if this fabric is unidirectional, then realize that it doesn't have any strength in the transverse or 90-degree direction. So this could be really both a blessing and a curse. In one sense, you're not wasting your material where you don't need it. So typically, for example, when we are strengthening a beam, we would put a unidirectional fabric on the bottom of the beam, let's say, pretty much the whole span, to strengthen it for flexure. But then when we want to strengthen the same beam for shear reinforcement, we would take that unidirectional fabric and wrap it near the ends of the beam in the hoop direction, similar to how you would install a stirrup. So the fibers in the ends, the fibers need to remain vertically. And this is one of the things that, other materials, engineering materials, like let's say steel, has the same strength in X and Y direction when you make a plate, if you take a plate of steel. With composite materials, that's not the case. And depending on what amount of fibers you have in each direction, you as the engineer get to control the strength of that, which is really it's a unique but great opportunity to use the materials very efficiently.
Yeah, I was wondering about that too. So for the typical structural engineers that are doing the retrofit, how does that work with, let's say for QuakeWrap, would the engineer of record design it, or would you be some type of consultant? Or
Yeah,
I guess that's something that we don't usually learn in school in terms of the typical engineer.
exactly. You're right. Unfortunately, these FRP products are not covered in a lot of, in hardly any university curricula. But there are, just so that your audience knows, ACI has a document, the ACI Committee 440. They have a design guideline for design of externally bonded FRP products. And it's very prescriptive. You can actually go through, in fact, at the end of that document, they provide a few worked out examples. So it's really easy that you can follow and do. So oftentimes we work with, we would like to really not become a competitor to the engineers on their projects. We want to be, collaborating with them and become a part of their team if they need it. So we have done different ways. There are sometimes we see drawings that, construction drawings where the consultant has prepared the drawings, and then on the drawings, they mark on every element, let's say on every beam that requires strengthening, they write a note that this beam, the strength of this beam in flexure has to be enhanced by so much, and in shear enhanced by so much. And then they require the material suppliers to provide the design subject to approval by the engineer of record. So that's a very common way that that we would do it. But we also, because we have our own construction company, we do the bulk of the work that we do is design build, where the clients may find us and come to us. We provide the design as well as the construction and just take it from A to Z. And we find that approach also to be really nice and much easier for the owners too. And this way we give them a, we stand 100% behind the work. If anything goes wrong, we are the only company that is responsible for it.
Gotcha. And I know you mentioned earlier before you were originally using it for seismic retrofit, but then it seems like a big part of it now is doing infrastructure repairs in water and on land too. Could you talk more about those? It seems like there's a
Yeah.
lot of corrosion projects, and I know corrosion is a huge deal for concrete. So can you talk about a little bit more about that?
Yeah, absolutely. Because as I said, although our original strength was for seismic application, then over the years we have kind of found a lot of additional, useful applications of these materials. So one of them is in the area of repairing structures underwater, and that relates to some of the products that I have developed. So these we can, for example, the fabric, you have to bond it directly to a surface, and that surface needs to be smooth. And if it is, damaged or rough, you have to first trowel it with some patching material, get it smooth, and then wrap the fabric. Well, one of the products we have developed is a very thin laminate that the laminate doesn't need to be, in fact, we do not bond it to the surface of the structure. But let's say if you have a column that you want to repair, you can take this laminate and cut a length of it. Say you cut a length 4 feet wide. It comes in 4 feet wide roll. So let's say take a 10, 15 foot long piece of this, and you wrap it around itself, around the column, and you glue it to itself to create a shell or a tube around the column at a distance, a couple of inches away from that column. So that then you can fill that annular space with rebar or concrete or what have you to strengthen the column. And the same thing, we can do that when repairing underwater. So we usually take like these 4-foot laminates and we can assemble them at water level, the first 4 foot around the pile, and then we lower it a little bit, put another 4 foot on the tail of it with like a 4-inch overlap. We lower the 8 foot, then another 4 foot, to 12, 16, and so on. So we can create a shell around the pile that can be sliding up and down until it goes down to the elevation that we want. And at that time, then we fill it with concrete or rebar or grout or whatever is needed. We can also place reinforcing bars along the side of the column. So this is really one of the things that we do in water. And it's been tested by the Army Corps of Engineers, Caltrans, Texas DOT for repair of steel H piles even. This is one of our biggest selling products called Pile Medic. And in fact, because with the name QuakeWrap, it was kind of in some of the products that we had, QuakeWrap was a little bit confusing for people to see what we do when we went to some of these shows. So we have a division called Pile Medic that has all of our marine repair solutions. And this pile, these laminates are one of them. We have another system where we make these panels that are very rigid, but made with FRP. And say, if you picture like a panel that is 4 foot wide by say 20 foot tall, and in the field, we assemble these panels in front of a deteriorated seawall that is corroded, like bulkhead or seawall or sheet pile. We put it in front of it, connect these panels at a distance again from the wall, and that serves as an impervious stay-in-place form, if you will, and then we can fill the space behind it with concrete or grout. So the whole thing really on all of these corrosion solutions that we have provided, keep in mind, the main purpose is to keep oxygen away from the host structure, because that's really the main source of corrosion. And, in a simplified way, if you look at, why do we buy a steel column and brand new start painting it? Because that paint is going to keep the oxygen away from it and, prevent the column from oxidizing and corroding. Well, we think of it like, these FRPs that we put are not only they provide some strength, but they're also like a very thick layer of paint, if you will. It's just going to be there forever and protect that host structure from, from corroding. So that's really one of the things we do for the marine applications. And then we have a whole different division of the company that has all kinds of pipeline repair solutions, and that we call pipemedic.com. Similar name, but it's called PipeMedic. And in that we have, right now, for example, and it's funny because I kind of got into this thing, as when I was a student in school, or even when I was teaching as a professor in structural engineering, we don't focus a lot on like pipeline design or how.
Yeah.
But who's gonna do? Somebody has to do that problem when you get out, ultimately. So in fact, we have a grant right now from U.S. Department of Transportation, over $1 million, that we are developing a system for repair of oil and gas transmission lines. And, we don't think about the buried infrastructure so much because it's kind of out of sight, out of mind. But there are 319,000 miles of oil and gas transmission lines in US alone. 319,000 miles. So you look at really like the opportunity for coming up with a repair system. And the one that we are developing is very much, I call it, is like an industrial stent. So we are making a robot and with a balloon, that around the balloon, we would wrap these layers of carbon and material. And then the robot would go into the pipeline and go to that point that the repair is needed. Then we inflate the balloon and the material sticks to the surface of the pipe. Then we deflate the balloon and pull it out.
Oh, interesting. Yeah.
And all of this is done, all of this can be done without digging a trench. So it's called a trenchless technology. But this is kind of a whole new world that I was introduced to in the last 15 years or so. And I know, some of your audience members, they should look up, like the terms trenchless, for example, and see there's a whole world of conferences and all kinds of meetings and innovation in that whole world about repair of pipelines. And there are a lot of other things to do, above and beyond beam and column design.
There's a lot. Yeah, that was really interesting. I know it seemed like with the marine projects, at least, it seemed like it was, so I guess if you're an engineer and you have a concrete pile in water and you want to repair it, that's not a straightforward solution off the bat. It's like it's existing, you got water around it. So it looks like what you do is you kind of get a FRP shell, you put it around it, and this is all without dewatering or anything. You just put it around the pile, and then you put in whatever reinforcing you get, either it's grout or steel reinforcing, and
or
not
FRP
only that,
reinforcement.
So that's the thing. It's like waterproofing, and it's like structural waterproofing. And the same thing with I think you were mentioning the dams or the seawalls. Exactly. We don't want water getting into the existing steel reinforcing. So not only do you reinforce it with FRP, but it's also waterproofing. So that's a pretty cool solution.
You're absolutely right. It's really, and one of the things, like the challenges for construction underwater is, if you have to build a cofferdam, for example, that could add a lot of cost, to build the cofferdam, dewater it, and then do the report. So these solutions that we have developed, they can be done, like we have epoxies that cure in water. So you don't need to worry about dewatering around the pipe. And, and those are really some of the features of a solution that could make or break the product, because if you can avoid, the cofferdam, just all of a sudden you have saved the owner a lot of money on their project. And then the other feature of like this, this PipeMedic laminate. So I should really like I should mention to some of your audience that why. So prior to me developing this PipeMedic product, what the industry was using, and even today there are some people are using, you would actually have to order like 2 half shells, to which more or less would be the size and the shape of the pile that you're trying to repair. These half shells would be built, in some place, shipped to you, and then you put them together and you bolt the seams or glue the seams together. But when you do it this way, you ultimately are going to have some moisture getting through that joint. So you cannot really, you're not protecting the column totally from the environment and corrosion. And from a structural point of view, if you look at, as a professor, I can never get away without lecturing. So my apologies, but I feel like I have to educate your audience.
Yeah, sure.
So when you apply an axial load to a column, that causes, that near the failure point of this column under an axial load, the materials dilate and they want to push outward. So if you wrap the column or confine it, it can take a lot more load vertically, even though you're wrapping it in the hoop or horizontal direction. So we use the same concept. And if you look at like some of these other products that they were being used before, if you put 2 half shells together and bolt, the seams along the height of the column, well, when you load the column axially and this jacket wants to move laterally outward, those bolted connections are the weak point and they're going to break. But in our system, as when you go like 2 wraps around the column and wrap the laminate to itself, now you create a product that is 360 degrees the same strength, and you don't have a weak point. And that, and then you can actually, as a structural engineer, you can calculate the effect of that confinement. So in some of the jobs that we do, you may use a 4,000 psi concrete in your grout or in your column, original column, but by virtue of using a confining shell around it, you can make that 4,000 psi concrete to work like 5,000 psi. So you get a lot more strength out of your column, and that's another benefit of this system.
Yeah, I know something that was drilled into us during grad school was for columns at least, was the confinement. The hoops were so important. That's why whenever we retrofit stuff in earthquake country, it's those hoops. Like those not only keep it ductile, but like you were saying, you can put more axial force based on testing. I think the PM diagrams don't take into account
You're absolutely right.
The hoops, but by testing it, that thing confines the core. So it's I don't think it's in the code yet, but for us structural engineers in California, the hoops, they're great.
It's funny because we work a lot, all over the country, and in fact, globally, and it's amazing that I see the practice of structural engineering, how different it is on the East Coast from the West Coast. So like in Florida, even in brand new buildings, you would be hard pressed to find anybody that uses a tie, more closely spaced than like, 10, 12 inches. And I always argue with these engineers that, look, this is not that much money. Put a few more ties in there. This is, you buy yourself a good, insurance policy at least, But and that's really what I think happens is that, if you don't put enough ties in the construction to begin with, and then you have a little bit of it because of corrosion, some of these ties, break. Now you're really, you're in a dire situation because you have these columns with virtually very little lateral support, tie.
Yeah, and if corrosion gets into the core there and you don't have hoops, that's pretty much it. It's really interesting. Did you have any more examples of infrastructure repair that you wanted to go over? Because it seems like there's a lot of cool projects that you could do.
We could, we get it's funny because in our office every day, we get calls of we don't usually get a lot of like, unlike most consulting firms that maybe you get a big multi-million-dollar project and you spend 2-3 years designing it. We are not like that. We every day, the phone rings or somebody emails with a something that went wrong. It could be something that was really urgent and happened, like like a contractor calling us that, we were drilling for this shaft of a bridge and we hit this sewer, 48-inch diameter sewer trunk, and now we've got a hole in the sewer from the top, and we need to fix this thing, quickly.
Yeah.
That, or sometimes, like something recently that we just did, and it's kind of really sad, for our profession, but there's a very nice, like mansion type building getting built in the Bahamas. And during the construction, they still haven't put all of the finishing touches on the building, but they did some core testing, and they realized that a lot of the cast in place concrete in this building, instead of being 4,000 PSI, it's testing at like 1,500, 1,600 PSI. And it's just a shame, like they have spent all this money on this building. Luckily, at least they've noticed that, before it was too late. So we've, flown our employees out there to fix it and, put some strengthening of some of those elements. But that, there's, we see, that kind of lack of attention, and improper maybe supervision, people trying to really cut corners from, putting an extra sack of cement in the concrete, and then just like the cost of fixing it, it could be so much more. We also see a fair amount of other type of construction errors or omissions. Like there was a bridge we were fixed, several years ago, 15 years ago, on Interstate 10. This portion of the bridge that goes through New Mexico. And so the contract, they were building two identical bridges. These were like 9 span, each of the bridges, like a slab bridge, and relatively short spans, about 25, 27 foot long spans, 9 of them on each of the bridges. So they finished one bridge, put all of the traffic on that one. This is the westbound was finished first, the one that comes towards California. And then, so all of the traffic both ways was going on that one. Then they were building the eastbound, and during the inspection, one day the inspector tells the contractor that it doesn't look like you're putting enough steel in the deck of this bridge. He says, no, this is exactly how I finished the westbound. So they take a look at, they see that he had left out half of the steel from the deck of that westbound bridge. Instead of putting number 9 rebars at 6 inches, he had provided number 9s at 12, on that finished bridge. So when we looked at, of course, the eastbound bridge, they caught him, early enough, and they put the right amount of steel in it. But when you looked at the westbound, you could see it. I remember being next to it as these trucks going over it, and it was just like fluttering and vibrating so much. But so anyways, but that was like one of the nice applications of these FRP products. Instead of tearing down this brand new bridge, we went from the underside of the slabs and put fabrics, directly bonded to the tension face of the slab. And, that bridge has been in service now for 15 plus years, and you can never tell the difference when you drive over it. It's just, doing really well. So
do they just paint over it just so to make it look like nothing's ever happened?
Yeah, you could stucco over it, paint over it. In fact, I'm glad you brought this up, because sometimes on these bridges, especially, it could be because some homeless people make it a home. So having a little bit of that carbon fabric, with the texture and color of it exposed, it raises the curiosity in some of these folks, and they may want to poke at it, which is not the strongest suit for FRP products. So it's better to hide them from view, and putting like a stucco over it is not a bad thing, especially when people are living very close to it and looking at it every day.
They're curious. What is this? Maybe I can pull it apart.
Yeah, that's that.
It's really interesting. I wanted to jump into your career path because it's not the conventional, I would say, for a structural engineering student. Could you take us through that? What challenges that you go through and how you made your career path decisions?
Yeah, so you're right. I thought when I started my career as a professor, I thought this is going to be, I'll retire as a professor. That was my vision at the time. But then, life had different plans for me, I guess. So we started, in this field of FRP, as I mentioned to you back like some 35 years ago. And I think this is interesting for your audience to realize that, anytime you introduce a new technology, it is such an uphill battle to get the society and profession to accept and, ultimately embrace, these new innovations that you put forward. So in this case, for example, back, and again, now, some of your audience have already, they've heard of FRP, but I'm talking about 1988, 1989. Many of you maybe weren't even born then. And, going and talking to like potential clients that we want to use this new product that we are testing, and it's going to do this and that, and it's going to be longer lasting. There are a lot of naysayers out there, and maybe rightly so for engineering and civil engineering, especially with, we are conservative in nature. But the point is that if you are passionate about what you do and believe in, in what you're trying to achieve, then you should stick with it, and be ready to have a lot of failures, because this is a lot of disappointments by people rejecting your idea, your proposals. But if you deep in your heart believe in this thing, you should stick with it, and ultimately, hopefully you'll see that these people will come around. But it is true that this kind of it is not something really for everyone, because I can see that a lot of people would, sometimes I look at and say, oh my God, how many times I was so close to giving up, and I just I said, no, let's just go dust yourself off and get up and keep walking and see what comes. And, but if you do that, then ultimately, hopefully you'll get to see, the fruit of your hard work and the decades that you spend on, doing something you believe in. But we've been, I've been really lucky in my career. So after, I think finally, when I had formed the company as I said, in 1994, and at the time I was still a professor, and I stayed there another 15, 16 years after that. But being both a professor, having this business, and having being a professor, it just wasn't really, such an ideal situation. And so I finally decided that it's better to, if I had to quit one, I wanted to stick with this thing, which was my baby and passion, and I would just say, let's give this a try. And so I left the academic community. But this has been, it's even, at QuakeWrap, I think, just again, so for some of your audience benefit, I did not end my interest in research and development when I came. In QuakeWrap, we have our own R&D lab in the company. I don't have to, the good thing is that, if we want to do something, we have our lab technicians do it quickly. We don't have to wait for government grants or, funding cycles and seeing whether somebody gives you the money to do it or not. So in some ways, this is really more interesting that you can, if you have an idea and having access to your own facility and lab, you can just, test it. And of course, we team up with some other universities for some larger projects that we do for R&D, but quite a bit of it we get to do in-house as well. So it's a combination of all of those. And as far as really what I do, you were asking, on a daily basis, it's a little bit of this and a little bit of that. I love to do some quick design calculations, and I'm teased by my engineers at how I do it literally at the back of an envelope and quickly give them an answer. But we do that. Of course, owning a business, you have to. I also enjoy interacting with our clients. So I go to a lot of trade shows. We have exhibits, to meet clients and then follow up with them. Sometimes, if it's a larger project, we may have to, go to the job site or meet the client, fly wherever they are, on the job site. some of it administrative work, of course, in the office, you have to, run, make sure everything, make sure that there's money for everybody's paycheck by the end of the week. So
Mhm.
those are, you know, but, I should tell you that don't be afraid of not doing these things because you think that, oh, I didn't go to business school or I didn't. No, that's not it.
Yeah.
If you are
Mhm.
passionate about something, get into it. And there's always, help that you can get. Like, if you need help with accounting, you can hire someone to do your accounting for you or outsource it. And but pursue your passion. That's really, life is too short not to enjoy what you really love to do. And why I consider myself really blessed is that even at this point in my life, I am so excited every morning to get out of bed and come to work. I don't consider this really work, and I think if you love, what you do, then this is why, you don't mind putting the long hours that it takes for you to be successful. And you should always, look for something that you like to do, passionate about, and stick to it.
Yeah, finding what you're really passionate about, and I think finding your purpose too. I think you had a good purpose to drive you to do these things, and then your career path kind of leads you to where you need to go. It doesn't need to be the
Yeah,
typical academia or structural engineering career, design projects, but pursuing something that you're really passionate about. And I think your entrepreneurial mindset of, okay, I don't know how to do that, but we'll
but
figure it out.
no, absolutely, I agree with you. And to further your point is that once you get into the business world, you really don't know what other opportunities come your way. You can never predict it.
Mhm.
So, for example, if somebody had told me uh, 20 years ago that you are going to be the only company that receives this grant from U.S. Department of Transportation to develop a system to repair 319,000 miles of oil and gas pipe, I would say, what are you smoking? you know, but you get into the business, we gradually kind of some jobs came that the pipes required to be strengthened. So we started using the same system that we had to repair these pipes. And then another opportunity comes, so then I came up with this idea of building it with a machine that we have developed. It's called Infinite Pipe, where we build a pipe continuously on site. This is really just like totally a new concept compared to like how traditionally you make pipes in a factory, you ship them on a trucks, and then you connect them together in the field, and oftentimes then worry about why the joints leak. Well, with
Mhm.
this Infinite Pipe, we send the machine that makes the pipe and maybe another container of raw material. They could be shipped to a job site anywhere in the world, and then the machine would make you the pipe on the spot. And then we can take the machine back and refurbish it and send it to another job. So it just becomes like so much less in transportation cost of it, because we sell rolls of fabric and drums of resin instead of hollow pipes that you have to ship. So it becomes very nice and compact to ship. But like all of these things, I would have never expected it. And I tell people that I'm very grateful for our clients to come to us with their questions and problems that we don't have a solution to, but it makes us say, hey, how can we solve this problem? And then that always
Mhm.
opens more new doors for you.
Yeah, who knew about pipelines and the whole world about that? But they got, yeah, like you were saying, there's problems, and as engineers, we can use our problem solving abilities to help them out.
Yeah, exactly. There's
Yeah,
opportunities everywhere.
absolutely. Mo, thanks so much for joining us and talking about this. That was really interesting about hearing about FRP and your career path as well. And uh, how can our listeners connect with you?
The best way really is to visit our website QuakeWrap.com if you want. My email, I can also tell you, it's very easy. It's my first name, Mo, M-O, at QuakeWrap.com. So shoot
Mhm.
me an email. I love to hear. I'm always really I enjoy talking, especially to the younger engineers in the beginning of their career. If I can provide you any guidance or advice, I'd love to do that. Or if you just want to chat, I'm always open to that. So I appreciate the time and opportunity to talk to you and your audience today, and I really enjoyed our discussions today.
Yeah, thanks so much again, Mo.
You have a great day too. Have a great day.
I hope you enjoyed the episode today. We'd love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, which is episode number 101, as well as links to any of the resources or websites mentioned during this episode. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcast. Until next time, we wish you the best in all of your structural engineering endeavors.